Hello and welcome to this series on microeconomics tutorials. Today's topic is price elasticity of demand. We'll begin with a definition. Price elasticity of demand can be defined as a measure of responsiveness of purchase decisions to variations in the prices. So price elasticity is looking at how consumers will change their purchase behavior when a supplier changes their price. Mathematically, price elasticity is defined as the percentage change in the quantity of a good demanded that results from a 1% change in its price. We will proceed to understand price elasticity with an example. In this example, we're given a demand function. Quantity demand equals 800 minus 45p. And we're asked, calculate the price elasticity of demand when price is 14, when price is 9, and when price is 5. Calculate the total revenue at each price. As a reminder, elasticity mathematically is the percentage change in price divided by the percentage change in quantity times price over quantity, or the slope of the demand equation times price over quantity. For this example, we are going to use this second definition since we are given the slope here, which will simplify our calculations. To solve this problem, again, we're going to use this equation, slope times price over quantity equals elasticity, and we substitute slope to be negative 45. Again, we got the slope from the demand equation. To simplify this problem, we're going to fill in a chart with positions of price, quantity, elasticity, and revenue. We are given that price is 14, 9, and 5. The next step is to solve for quantity. We could do so by plugging in price into the demand function. So here, if we plug in price, we're able to simplify and solve for quantity. First, we are told that price is 14. So in this case, we plug 14 for P and solve for Q. So Q in the first case is 170. Next, we are given a price of 9. Again, we plug in 9 for P and solve for Q. Q in this case is 395. Our last price is 5, so we take 5, plug it into P, and solve for Q. Our Q here is 575. We have now found the quantities at the respective prices and fill them into our chart. Our next step is to find elasticity, and to do so we will use this formula, slope times price divided by quantity. Again, we are going to use this formula to calculate elasticity. In the first case, we know price is 14 and we found quantity to be 170. So plugging that in, we have elasticity equals negative 45 times price of 14 divided by quantity of 170. And here we get negative 3.71. Now you may be wondering, what does this number mean? Well, elasticity is a measure of responsiveness of purchase decisions to small changes in price. So in the first case, a 1% rise in price leads to a 3.7 reduction in the quantity of goods demanded. So the next case, we are given price is 9, and we solved quantity to be 395. Plugging this into our formula, we get an elasticity of negative 1.03. To interpret this, we say a 1% rise in price leads to a 1.03 reduction in the quantity of good demanded. Finally, when price is 5, we have a quantity of 575. We plug these values into the elasticity formula and get 0.39. To interpret this, we say a 1% rise in price leads to a 0.39% reduction in the quantity of good demanded. As you notice, as elasticity becomes less negative, consumers respond with a smaller reduction in the quantity of good demanded when price changes. That is, they become more inelastic to changes in price. Once we have found elasticities, we could fill them in to our table in this position. Our final step is to find total revenue. Mathematically, total revenue is price times quantity. Conceptually, total revenue is the dollar benefit a seller makes from their sales. So let's calculate it. Using this formula, when price is 14 and quantity is 170, we multiply them together to get a total revenue of 2380. When price is 9 and quantity is 395, we multiply them to get a total revenue of 35.55. Finally, when price is 5 and quantity is 575, we multiply them together to get a total revenue of 28.75. We have now found our revenue values and fill them in to this position of the table. At this point, you may be wondering, why do we have to calculate elasticity and then provide a revenue? Are these values somewhat related? And the answer is yes. Elasticity and revenue are related. This is how. A price reduction will increase total revenue if the absolute value of price elasticity is greater than 1. Let's look at each row to understand this concept. So in the first row, we have elasticity of negative 3.71. The absolute value here is 3.7. Since the absolute value of elasticity is greater than 1, we can conclude that a price reduction will increase revenue. Looking at the second row, elasticity is negative 1.03. Its absolute value is 1.03, which is greater than 1. So at this position, we know that if we reduce price, our revenue will increase. Finally, elasticity is negative 0.39, absolute value of 0.39. 0.39 is less than 1. So according to this rule, if the price falls, revenue will not increase. So at this position, it is not wise to reduce prices since the seller will not become better off. And that's all for this tutorial. Thank you for watching.